call this surface area.
Start recording.
Okay. All it is, if we have a three-dimensional shape, like a rectangular prism, just like that. You draw two rectangles and then connect the corners. Okay. First thing we're going to look at is how to break that down. So we call these nets. And all we do is we take the individual shapes. So on a rectangular prism, what shapes do you have?
A square and a rectangle.
You have rectangles. You can't assume they're squares. So how many different rectangles are there?
5, 10. No.
6. Thank you for saying 6. I know you were probably thinking.
Why does it say net, chick nets?
So we take 4 rectangles to represent the front, back, top, and bottom. And then we're going to have 2 more off to the side to represent our 2 bases. And it doesn't really matter where they go. You just need to have 1 on one side, 1 on the other.
Does it have to be?
It does not have to be, well, they have to be on opposite sides, but that's about it. So I could have put this one down here.
Is that kind of like those foldables?
Yes, that's exactly what these are.
Or you can make one.
Yes, so you could put one up here, one down there. Put them both, make it like a T or an elephant. The only thing you can't do is you can't say, you couldn't put it like that, because if we tried to fold this back up, these 2 here would overlap each other, which wouldn't work. So you have to have them on opposite sides. Okay? So why we do this, why we make the net is a little bit, or makes it a little bit easier to look at it. In terms of surface area, we want to find how much total area do we have on the outside of the shape. Okay, so kind of like how volume looks at what?
Inside.
On the inside, we have surface area, which looks at everything on the outside. So it is very much has to do with area. So why would we why would we need something like this?
You're finding out like
Measure outside the wall.
no.
So what would we be doing on the outside? Let's say it's a house.
Measure,
Oh,
Putting like a
Put
flower pots, flowers, like around
porch
the house.
around the house.
Well, flower pots would be more like the perimeter on the outside. Why would you need like all the walls? If you're painting, right? Because you wouldn't need volume for that. We don't want to fill the house with paint. You'd probably get fired. We just want the outsides. So that's what we do surface area for. Okay? So we make the net because instead of looking at it as a three-dimensional shape, could we find the area of each of these rectangles?
Yes.
Yes, because we've done that. That's just length times width. Yes, sir.
Why don't you just find one area and use the same thing for a whole thing?
You couldn't use it for all of them, depending on what the side lengths were. Like this one, since these all look the same, these 4 would probably have the same area. So yes, if you found the area of one, you could say, take that area, times it by 4, okay? So let's, actually we can put in some numbers here and let's try it out. So let's say if this is 5 by 5 by 7, okay.
Well, that's basically the same.
So now if we look, what would this side right here be? 7. How about all these?
No, 7.
These would all be the same length. They're all 7. How about this side right here? That'd be 5, which means all of these would be 5. And how about this side right here?
5.
That would be 5. Because if we look at this shape right here, what does that match up to on our prism? The top, bottom, front, back, or the sides? These are the 2 sides. So this side is 5 by 5, which is why this is 5 by 5. And now we just look at the area of the individual shapes. So what's our area here? 7 times 5 is? Okay. How about all these 3 below it?
35.
Those would be 35 as well.
Except for these side boxes.
Then we look at the 2 on the side, which are 5 by 5, so that would have an area of 25.
How do you know which one's height when you say 5?
Wait, what?
Like, you know how I say 5 by 5? How do you know which one's the height?
You mean as compared to like base and height when you're using the formula? It doesn't matter. Since you're multiplying them, it doesn't matter the order you multiply. Like 7 times 5 is the same answer as 5 times 7. So when you have a rectangle, you're just multiplying the 2 numbers you have by each other.
I thought you said we were staying on shapes before.
This is shapes. This is like extra shapes. This is shapes within shapes. This is shapeception in here. So to find the total area, what would we do with these 6 individual areas?
Multiply it.
Not quite. You just add them up. So we say, what's 35 plus 35 plus 35?
Just do 35
Yes, you
times-
could. There's any number of ways you could work this out. I go with the most straightforward, which is just addition. So 5, 5, 5, 5, and 5 adds up to
25.
30. And then 5 threes is 15 plus 4 is,
19.
you had it, you're just a little ahead of us. So our the whole area of this entire shape would be 190. Okay? So this is our surface area.
Oh, so surface area is just the whole thing.
Right.
Can't you just multiply it by 4 and then times 2?
You could. Someone asked, would that be squared? Yes, this would be whatever your units are, squared. Since it's just area, it's still in 2 dimensions.
No, that's a 3-dimensional shape.
But what we're looking at, since we're just looking at the area of the 3-dimensional shape, we're only talking in 2D.
For the...
Wait, hold on.
So area is only for like the 2D shape?
Yes, area, we can only find area of 2-dimensional shapes. Okay. All right, so that's the basic idea. So let's look at, on that paper we gave you, number 1. It says a rectangular prism. What shapes is that made up of?
Rectangle.
And we'd say rectangles. It wants to know how many are there.
4 or 6.
There are 6 total, so we say there are 2 base rectangles. And then we would call the other ones 4, we call them lateral rectangles. So that's what lateral means. Lateral is everything that's not the base. So if we talked about lateral surface area, what do you think we'd be finding?
And just 4.
Bases.
Like the faces, yeah, the sides.
We would just find the sides. So if we were looking at this one,
We're going to do the top and bottom.
depending on which shoe we wanted for the bases, we would only be adding up 4 different areas. Okay? Lateral surface area is kind of a big deal. With our painting example, if we think of that, would we paint this entire house, all 6 faces of it?
No, the roof.
Because we wouldn't paint the roof, we wouldn't paint...
Well, unless you wanted to like.
No, we're not looking at special examples where we paint the floor.
No, not the floor, the roof. You can paint the ceiling.
Technically.
Gross.
But in general, when you're painting a room, you want to paint the 4 walls and you leave the floor and the ceiling alone. Okay? If you paint your floor, your parents will probably be mad at you. Probably. All right? So our next shape, we have a pentagonal pyramid. So we need to look at how to draw pyramids. So the simplest way, you take whatever shape your base is. In this case, it's a pentagon. So we draw ourselves a pentagon. 5 sides. Doesn't have to be perfect as long as it's got 5 sides on it. What do you mean it's upside down?
That's the base.
How? What? All right. Since it's a pyramid, how many bases is it going to have? Just one. So we're not going to draw a second pentagon. All we're going to do is we're going to put one vertex up top. And then we're going to connect that top vertex to every one of our vertices on our base. And sometimes it comes out looking good. A lot of times it comes out looking pretty bad.
Wait, where's your shapes thing?
But you get the idea.
Shows us the shapes.
The shapes thing?
No.
You mean the actual three-dimensional
These
shapes?
things.
Yeah, we'll pull those out tomorrow.
Shapes.
The easier way to draw these is to actually make the net. The net of pyramids is really straightforward. Again, you draw your base upside down, I guess. And then you just draw triangles coming out from each one of those. This is even worse than the first one. So 1, 2, 3, 4, 5.
It's a star.
And you get sort of a Patrick kind of looking thing.
We need to make it fatter.
What shape are what color are shorts? Green.
Green with purple flowers.
Purple flowers. How do the purple flowers go?
They look like SpongeBob
Here?
flowers. Like the one in the sky. They go
Like the clouds. The
clouds are like
the
I
flower
don't know
clouds.
what SpongeBob
Yeah,
is.
I don't actually watch SpongeBob. I don't know, but all I know is it kind of looks like he's wearing a bikini. All right, but you get the idea. So what shapes do we have here? Ashim?
Triangles and
This kind of creeped me out, so I'm gonna. So we do have what? We have one base that's what shape is the base? Pentagon. So one pentagon and what? Quickly. And 5 triangles.
Is it lateral or no?
Those would be considered the lateral faces, yes.
Would they always be lateral?
Yes. Okay. And now we can see the fundamental difference between prisms and pyramids. So we're going to add that to our notes real quick. So off to the side of our shape here. So we have any prism we have has how many bases?
1, 2.
2. So a prism will always have 2 bases. Okay? And then the rest of the shapes on that prism will all be what? Rectangles. So every prism you're ever going to see is going to be made up of the 2 bases, whatever shape that base might be. Oops. Plus a bunch of rectangles. Okay? And down here, it's still kind of creeping me out. Stop looking at me, Patrick.
Make him say.
We have pyramids, which have how many bases?
1.
Just one base. And what is everything else?
That word. Triangle.
Triangles. Okay? So if you can remember, prisms are 2 bases and rectangles. Pyramids are 1 base and triangles. And that'll help you through almost all of this. Okay? So let's go back. Number 3, our only other different one that might cause some confusion is cylinder.
Bases are circles.
Would have 2 bases that are circles. And what else? And 1 rectangle. And you can sort of
Because it wraps around.
You can sort of cheat your way to that answer because if you look lower on the page, it gives you that drawing.
You know what the benchmark? Can you tell us?
No, I can't.
Oh, yeah.
Because we're not done. So let's look at why it's a rectangle.
Oh, we got Patrick out of the
Yes. So if we have a cylinder, and let's say,
We have to draw that.
yes.
Good soup.
Okay.
Is that the new brand?
So if you imagine a can of soup, right? Or a can of whatever.
Good soup.
If we take the can opener, we take the top off, what shape is it?
Circle.
It's a circle. Okay? If we cut the label off of it, what would it look like?
Rectangle. Is the rectangle just wrapped around it?
Because the label is just wrapped around the cylinder, it just makes a rectangle. So our label would look like, you'd have the label on the front part, you'd have the barcode and your nutrition box on the back.
Then why is it called good?
Because the fat is what makes things taste good.
Oh, fat?
No, there's no cats in the soup. Unless there is. Alright? So, this middle section of a cylinder is always just represented by a rectangle. If you don't believe me, go home and find like an empty paper towel, little roll, and if you cut it and then fold it out, you'll get a rectangle.
But what if it's like what if it doesn't have a, what if you mix a square?
Then a square is still a rectangle. Alright, so in addition to that rectangle, we do have one circle above and below. Those circles can go anywhere
Then why is that one?
because it can go anywhere it wants.
Wait, isn't that just the wrap? What's the real circle? I mean, rectangle. Isn't there like
You could always turn it that way, get the same thing.
Mr. Ellis, wouldn't there be on a soup can 2 rectangles?
No?
Yeah, because that's just a wrap. That's covered around the real. Like, cause you know the can, cause you know the can's all metal too. Yeah, and then they put the.
Yes, technically the actual physical can itself would be. Alright, so we should be able to take a minute here. You should definitely be able to get 4 and 6, and then just think about what 5 might be. Ready, go. I don't look at the test. We'll go over it hopefully next week. Probably not tomorrow because we're still missing people who are out. Alright, so number 4, triangular pyramid would have one base triangle. Don't erase what you put, you're probably right. I'm just going to make it more confusing. One base triangle and 3 lateral triangles. So if you put just 4 triangles, that's fine as well. That's the same idea. Because the number of lateral faces it's going to have will always be the same as the number of sides on the base. So since the base is a triangle has 3 sides. That's why we have 3 lateral faces. All right, how about number 6? 6. We're skipping number 5 right now.
6,
We'll have 2 hexagons for the bases and 6 rectangles. Because again, because it's a prism, it has 2 bases, which would be hexagons, plural. And since a hexagon is 6 sides, that means you would have 6 rectangles to connect them. And I have a picture of that somewhere. Yes. Somewhere here. Maybe I don't. Oh, here it is. We sort of started to draw elephants and stuff. I don't know what happened here. All right. So here's our drawing of a hexagonal prism. And to make a net of that, you take those 6 rectangles and put them all down the middle. And you take your 2 bases and put them off to the sides. And again, these could go just about anywhere on here, as long as they're on opposite sides of the shape.
So can you put the elephant back?
No, I can't.
Who drew it?
I did. Jeremiah, I hear everything you say. Number 5. This one's a little bit different. This one does have 1 circle. And the rest of it is not really a shape that we have a name for.
But you can make it.
I mean, we could make it.
Would it be like a curved triangle?
Yeah, like that.
And you'd get something like this. But to say it's a curved triangle, a curved triangle or a Pac-Man are not names of shapes. So, okay. It does have the circle and the second piece, but this piece doesn't have a name we would be working with, so we're just going to leave our answer here as 1 circle. Okay. All right, number 7 and 8. Draw a net for a rectangular box that's 9 by 5 by 3. So all you need to do is if you take the period at the end of that sentence and just make it a little bit bigger. And you should get a shape that looks like that. If that doesn't work, you're probably going to have to draw it. No. So draw the shape out. I'm nice enough to give you what the shape looks like, so don't complain. And which of these sides would be the 9? The one going from... Is this side any different from this side? This would also be 9. How about this one on the bottom? Also 9. It's a rectangular box or a rectangular prism. Okay, yeah, I know. I was there. So we'd also have this side here, which is 5, which is the same as this side and this one, and this one. And then all these short sides would be 3. Hopefully we're writing this down, not just waiting for something to happen. Hopefully tomorrow we'll be able to cut some of these out and see how this folds up.
We're gonna cut this out?
Not this one on this paper, I'll give you something else. Yes. Right? How about a net for a cylinder? So what 3 shapes should we draw here? We should have 1 rectangle and 2 circles. So every cylinder's net looks more or less the same. It's just 1 rectangle, 2 circles.
That's like number 11.
All right. So it gives us a height of 8 here, and it says the radius is 3. My question to you, the one that's going to make you actually think, is if we say pi is 3, just to keep it easy, what would be this blue length right here? Don't shout it out. Think about it. And yes, you have enough information there. No, you don't have to guess. The blue length. It is not 8. Wouldn't be. Please don't just guess. Please don't just shout stuff out. Use your formula chart. There's your hint. Okay, so anyone want to raise their hand, venture a guess of this? Robbie? It's not 9. It's not 11. It's definitely not 3. It's not 12. Cyan is correct. It is 18. Cyan, how'd you get that?
Did it by circumference goes to pi r.
Very good. If you consider that this middle section is just the circle unfolded, right? So that means that this distance from left to right is the same as the distance around the outside of the circle. So if we take, what do we call the outside of the circle? That's the circumference, which is 2 pi r. So 2 times 3 times 3 is indeed 18. So anytime you have a cylinder, one of the sides on that rectangle will always be the circumference of the circle.
Where'd you get the second 3 from?
The radius, which is given to us. The 2 is part of the formula. Okay? Something to keep in mind for later. All right, take 1 minute. You should be able to answer 9, 10, 11, and 12. What shape is number 9? It's a triangular prism. We know this because there are 2 triangles and a bunch of rectangles. How about number 10? Okay. It is. Pyramid part of the answer because we have one base. It's definitely not triangular. We look at if it doesn't. Since we can't assume it's a square, because it doesn't tell us all four sides the same, we have to call it a rectangular pyramid.
Isn't that what every pyramid looks like that?
No,
Then how's the base of regular pyramid?
there's no such thing as a regular pyramid.
Then what's the line in Egypt?
Probably rectangular. Like, here's a pyramid, yes? Sort of. Okay.
I can see how that would be.
All right, how about number 11?
Cylinder.
This is a cylinder. What kind of cylinder?
It's a cylinder.
Rectangular cylinder.
That's a trick question. There's only one kind of cylinder. It's just a cylinder. All right, number 12. What three-dimensional figure can be made from this net?
Triangular pyramid.
This is a triangular pyramid. Okay, again, because we have whatever shape is in the middle, that's how we name it. And you put triangles around the outside. Yes, whatever shape the base is, that's the first part of the name, unless it's a cylinder. Because cylinders don't follow anyone's rules. No. All right. Whoops, that's not right. All right, next part. On the back and also in your notes, we're going to add a couple more things. It says, use a net or formula to find the surface area. We showed earlier how to use the net to find surface area, and that works. And if that works for you, I'm not going to stop you from doing that, to break it down, find the area of each individual piece. But as long as we're in class, I'm not going to focus on that way, because the problem with that is if you look on your formula chart, which is where you should go anytime you're dealing with shapes, it doesn't say anything about how to do nets. So it would be up to you to remember how to make the net correctly to be able to use that to find the surface area. Okay? The other way is to use the formula. The formula is written on here. And it's a little bit harder to forget because, again, it's written on here. So that's what we're going to try to work with. So if we look under the category of surface area, and then you find where it says prism, and what formula does it tell us? Is pH plus 2b. I would write this down in your notebook. We're going to write down what all these letters mean, because it used to tell you, the chart doesn't tell you anymore what the letters stand for. 2b. So we're going to start with capital P, which will always represent the perimeter of the base. All right, capital B. What about the base? If it's not the perimeter, it's the area of the base. One somewhat juvenile way of remembering that, which I've been told by children, is that if you think of the big B, which kind of looks like a butt, and you think that a big B will take up a lot of area. Okay? But you do need to remember, because a lot of people will say, oh, big B, that's the base. That's not enough. You have to know big B is the area of the base. You have to be able to put this entire phrase together. Anytime somebody says, what does big B stand for? You say,
Big butt. Big butt.
let's try this again. Let's use our reading skills, okay? When I say big B, you say that is the Okay, good job, most of you. Our last letter up here is H. When we talk about our formulas for volume and surface area, this H is kind of a big deal. This represents the height of the entire shape. So if we're talking about a prism, H represents the height of the prism. If it was a pyramid, H represents the height of pyramid. Hold on. Uh-oh. Okay, so the important thing when we talk about surface area of a shape is recognizing where the base is. So rectangular prisms are kind of special in that the base could be anything. In terms of keeping this simple, we're just going to say the base will be the top and the bottom. Okay? So what we're going to do is we're going to draw this out separately so we can see it better. And what are the dimensions on our base? Just the base.
5 and 12.
Are just 5 and 12. Okay? So now we're going to find what is the perimeter of that, what is the area of that. So what is the perimeter of our rectangle here?
34.
Would be 34. Remember, to find perimeter, we just add up all the sides, because it's perimeter. Okay? And then we look at the area, which is base times height. If you forget, you go back to the formula chart, you look for area of a rectangle. So 12 times 5 is 60. So once we have the perimeter of the base and the area of the base, we have more or less everything we need to know to find the surface area. So we're just going to take these two numbers and we're going to substitute them into our formula. So capital P is 34. Capital B is 60. Then we just fill in everything else. Well, not quite. So 2 is just 2. And then what is the height of the entire shape? Is, I'm out of colors, is 8.
Oh, would we do 8 times 4? 8 times.
No. Height is just one number. It's whatever. If you're not sure which number is the height, one thing to look at, it can't be part of the base. Okay? So it can't be 5 or 12. We can also look what side connects one base to the other. And that is these sides right here, which are all 8 centimeters. So the height of our prism is just 8. Once we have that, this is just arithmetic. That's multiplying and adding.
Wait, what's,
So take a minute.
is that 2 plus 60?
That's times. So it's going to be 34 times 8 plus 2 times 60. I'll do the right side for you. That's 120. I'll let you guys do the left side. $92, we agree? 272. 392. Oh, adventures in multiplying here. 4 times 8. 8 times 3 plus 3 more. So it is 272 plus 120 is. So that is our surface area. No? What I want you to work on until the bell rings, we're just going to work on a couple of these. You're going to try number 3 and number 10, because those are both the same kind of shape, so we can use the same setup that we used here. On number 10, no. Number 10, it says find the lateral surface area. We're just going to find total. So if you want to cross out where it says lateral there for number 10, we're just going to find total surface area for all these today. So try that. If you don't finish those 2, that's homework. Do not lose this paper. You need to bring it back so we can answer the rest of them tomorrow. Work on them now. Make use of your time. If you want to do the net for these, I won't stop you.